Hello, this is the course of Introduction to Data Science, and in this video I would like to discuss about data visualization. First, we want to show our data in terms of graph or something like chart, but why? Okay. Why? Yeah, there are some reasons for showing our data in the data visualization. First is like, we want to gain insight into the information space by mapping data into graphical. So graphical can be something complex or just a primitive one. And we can also provide qualitative overview of a large data set. So if the data set is very huge, we can immediately see the summary from the visualization. And based on the visualization, we can search for patterns, trends, structure, irregularities, relationship among data. So those kind of things can be done, and yeah, at the end, it will help you to find some interesting regions and also suitable parameters for further quantitative analysis. Yeah. So in this section, we are going to learn about one library which is called matplotlib. I think last time we already learned one example for the matplotlib, and also we also used the seaborn as one of the library to improve the quality of the design. So let's learn to put all the library before you start the code. Okay, so in this case, I'm using NumPy, Pandas, and the two are matplotlib. Here I would like to apply the method in a py plot as plt. So and time I call the graph, I will just use the plt. And now whenever I show it, I want to show it in line with the directly to the cell that I executed. So I will run this one, and let's see, I am using the data diamond. Okay, in the previous video, I think I already give you the insight about the diamond data, and yeah, this is the data of the diamond. And I would like to know according to the cut. Okay, so for example, I want to know about the cut. So the cut here, I want to know how many of them. Let's say, yeah, I want to know the cut, and I want to know the value counts. What is the value counts? So we want to get the numbers of rows that has a particular categorical data. So it means I want to know how many ideal, how many premium, how many good, and etc. And I want to store it into the variable table. And okay, this is the table. So the ideal contains of 21,000, premium contains 13,000, very good contains 12,000, and so on. Now I would like to plot into a bar chart. Okay, so what is this bar chart? So in the bar chart, I need to define at least two. So the first is the X and the other is the Y. Okay. In this case, the X is the index. So the index is ideal, premium, very good, good, fair. And the Y is the table. The table itself contains the numerical attributes, this one, 21,000 and 13,000 and so on. And after you, yeah, here is bar chart. So you can specify the bar, and then yeah, the X, what is the X, and then what is the Y, and then show. Okay. So this is the result. Yes, you can see that the ideal is 21,000 and the fair is 1,000. Okay, there's a very big gap. Although the result contains all information that we would like to convey, but yeah, the aesthetical is less than what we expect, because now we are in the 21st century. So there might be new data visualization. So that's why in this course, I think I will also use Seaborn as one of the library that have the higher level plotting routines. And it also can override the matplotlib default parameter in order to produce a superior output. So in the case of Seaborn, we need to use the Seaborn as, for example, SNS, and then you need to set it. Okay, you need to set. Now, let me repeat again. After I use the Seaborn, I want to show the bar chart that I previously shown. So here, yes, you can see it's a little bit fancy, okay, in terms of the text, and then in terms of the graph, you can see here there's nothing but the background, and here the background seems a little bit professional. Okay, so the next I would like to use another data set. So I hope that you can learn many kind of data set. So the IRIS dataset is one of the famous dataset in the domain of data science and data mining. Okay, and the dataset exists in the SNS. The SNS means the seaborne, embedded dataset. So using this seaborne embedded dataset, so the name vary. Okay, so if I use IRIS, then it is the IRIS dataset. If I use another kind of dataset, housing or something, it depends on the name. Okay. So this IRIS dataset, actually, it is a collection of flowers. Okay, so this is the flowers. Okay, so please remember that I use this one. I use the figures. Okay, the figures 3-2 figure 3 underbar iris.png. Okay, so please don't forget to also put these figures into the folder figures in your Jupyter notebook folder. Okay, so these are the colors, the flowers: Iris virginica, Iris versicolor, Iris setosa, and there are four attributes and one class. So sepal length, sepal width, petal length, petal width, and flower class. So you may familiar with this data set in other classes, but let me explain one more time. So this data set is based on the centimeters. So the petal and sepal, what are they? So sepal is the flower in this one, in this part of the flower, and there is another variable which is petal. So petal is the small one. Okay, so we want to check this one, the petal length and the petal width, sepal length and the sepal width, and based on those information, we are hoping to see the result, whether it is virginica or versicolor or sedosa. Okay, so after I extract the data from the seaborne, I would like to know the details. We have sepal length, sepal width, petal length, petal width, and there are 150 data. Okay, so we have 5 columns and there are 150 data, and 1, 2, 3, 4, 5. The last one is species. So if I want to see the first 5 data, the top 5 data, this is the result. So this is the first 5 data. Now we would like to make a histogram. What is the histogram? So later I will explain. In this case, I'm using the sepal length. Okay, you can modify later with the other kind of variables, but now let's suppose I use the sepal length, and I'm going to define the bins. Bins means the range from the data itself for every bar. Okay, now let's suppose I have 10. Okay, I want to make it 10, and I have the x level as the sepal length and the y level as the frequency. So I want to know how many sepal length in the how many sepal length according to this number, okay, and the range of this from 4.5 until 8, it will be separated into 10 pins. Okay, so you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10 pins, and for every pin it will show the frequency. So it means like this one, it is maybe around like 4 until 4.9. Okay, so there are like 8 or 9 something, and then if the value is higher than 4.5, then it belongs to this class, so it will be calculated and the result is about 23 something. Okay, now the important thing that you need to learn is what is the difference between bar chart and histogram. Both of them, they produce the bar chart like this one. They also produce the bar chart like this one. So what are the difference? Yeah, the bar chart is best used for reading numbers accurately from the chart, and it compares the individual bars to each other. So when you show this one, there will be a comparison between one bar and the other, and it explores overall trends across categories. So we can see the trend among the categories. But okay, the bar chart has the characteristic to show the categorical variable and the numerical variable. So usually the x is the categorical and the y is numerical. On the other hand, histogram shows the different one. So it's best used for to show the density and distribution of continuous numerical data. So if you want to see the continuity of the data, then yeah, you can use the histogram. So if you are using bar chart, if you're using bar chart, it means you want to plot the categorical data. But if you are using the histogram, it means you want to plot the continuous or numerical data. Now, let's suppose I have this one. I want to plot the sepal width and sepal length, and then I have the scatter plot. And the title is sepal width versus sepal length, and the x is sepal width and the y is sepal length. Okay, we can get this one. So this we call it this as scatter plot because you want to see the relationship between two dimensions, between two attributes. It is best used for showing how one variable affects the other, or for showing precise data density visualization, correlation, and cluster between two variables. Of course, the scatter plot requires two numerical variables. And when the third numerical variables can be added, then it will create a bubble chart. So the third variable changes the size of the dots. Let's see this one. I want to put the iris sepal length and iris sepal width and sepal length, and then the S. S means the third category. I want to use the petal length. And the remaining are the same. We have X label, Y label, and the title. Okay. So this one X label, Y label, and then title, and then show. Okay. Well, for the first time you need to show, but for the next thing you don't need to show because they are already in line with your cell. Now we have the S. S means this is the size. Okay. So if I just remove this one, my 20, yeah, actually you cannot see clearly because the petal length is very small value. So that's why it will be good if say I multiply 30. Okay, so you can see size is bigger and the other size is smaller. Okay, now if I want to plot the bubble chart with the, I think this one, okay, I use color. Okay, so S means the size, so the size will be based on the petal length and the color will be based on the petal width. So let's see if I change this one to 30. Okay, yes, that's cool. Okay, so you can see the relationship between sepal length, sepal width, and petal length, petal width in the scatter plot. And now I would like to show you if we want to make what the box plot. Okay, so the box plot, I will just need the variable to be numerical, so it cannot have the categorical data. That's why I need to drop. Okay, drop means delayed. The species means the column species, and axis one it means the column. And after I drop this file, I would like to create a new variable, new iris. So here is the data. Now we have only 4 without the species. Okay, so we have 4 attributes, and you can just do the box plots. So the box plots mean I want to get the data. Where is the data? Yeah, this is the new iris, and you will already set the column 0, 1, 2, 3, and the label will be the new iris dot columns. Okay, and after that you will show it, and yes, this is the result of the box plot. It seems that the sepal width is the lowest one. Okay, so last time we already learned how to interpret this box plot. So I hope that you can refresh what does it mean by this box plot. So here I would like to do the box plot, and then the new iris data is from 0 until 3, and then labels. Okay, the label means the new iris dot columns. Okay, so we can also do with the multi-dimensional relationship. We can just use the pair plot. So in this case, I will just use the pair plot and then call the data name, the data variable name, hue species. So I would like to distinguish the color based on the species, and then the height is 2.5. Yeah, actually you can manage the size later. So using the pair plot, you can see the relationship between 2 variables, so petals length and petal width. Okay, yeah, it's interesting. Petal length and petal width, oh, it seems like linear. Okay, yeah, if you want to analyze more, yeah, you can use this graph. So it shows you the summary immediately. Okay, so there is also another function, we call it the correlation. So the correlation among the numerical attributes is important. Okay, so now let's just use the heat map to see the correlation among the 4 attributes. So here I use the heat map, and the heat map call the iris.core. Core means the correlation value. Annotation true, so it means there should be annotated. Okay, and yeah, you can see here the sepal width and sepal width is 1, 1. So the relationship between those two same activity, those two same attributes, yeah, it refers to 1. But the remaining, yeah, it depends on the data. So the heat map is best used for showing general trends. And the data, which can be like the data grid of 2 numerical or categorical variables. And if you have the third variable, then it will be useful for showing the color. Okay. So I think I will stop in this section. I will continue the next section in other video, and please follow the rules in the e-class. In this case, you need to do the course-based quiz, so please check the details in the e-class. Thank you.